Next problem. This should be on worksheet 3, the one I just gave you today. It's number 3. It is Hess's law again. And we have it written just slightly differently than you saw before. They give you the data first, and then give you the equation you want, instead of giving you the equation first, then the data. Same thing, it's just kind of flipped. So in this case, let's do our steps like we normally do. We need to find from the data what we need to get our final equation. So in this equation, is there anything from equation 1 that we need for our final answer? No, there's nothing there, but it's going to need to be used to probably cancel some things out. Is there anything from equation 2 that we need for our final balance? Yeah, the P4O10. Equation 3, is there anything I need? PCl5. And equation 4, is there anything I need? The Cl3PO. Alright, so this one, our first equation is more of a canceling equation. So let's look ahead to 2, see what we need to do to figure out what we need to do with step 1. So step 2 has P4O10 that we need. Is it in the correct place? No. It is a product instead of a reactant. So we know we'll need to flip equation 2. And I'm not going to need to do any math to it because P4O10, they're both 1. We're okay. Now if I'm looking at my products over here, when I flip it, P4 is going to become a reactant. This one has P4 as a, P4 is going to become a product. This one has P4 as a reactant. It's going to cancel that P4 we don't want. So we need to do nothing to the first one. So P4 as a solid plus 6Cl2 as a gas is going to give us 4PCl3. And our change in enthalpy won't change because we did nothing to it. Reaction 2, we know we're going to have to flip. So it'll be P4O10 is going to decompose to be P4 solid plus 5O2. And because we flipped it, our sign will change to a positive 2,967.3 kilojoules. Okay. Is there things that we can cancel? Yes, that's why we set it up this way. The P4 is on both sides. They will cancel. I don't have anything else to cancel. So I end up with P4O10 plus 6Cl2 is going to decompose to 4PCl3 and 5O2. And my change in enthalpy at this time is negative 1,225.6 plus 2,967.3. So 1,741.7 kilojoules. If we look at reaction 3, it gives us PCl5. Is that PCl5 in the correct place? No, it is a product. We need it as a reactant. So we are going to flip it. We also need 6 PCl5s. The data only gives us how many? 1. So I'm going to need to multiply it by 6. So if I were to add it, it is going to be 6 PCl5, 6 PCl3, and 6 Cl2. And my change in enthalpy is going to go positive because I'm flipping my sign. So it's 84.2. And we will multiply that by 6. So it's going to be a positive 505.2 kilojoules. Is there anything I can cancel on both sides that are the same? I'm sorry, on opposite sides that are the same. Yeah, 6Cl2 is the same on both sides. It's gone. So when we combine all our stuff together, we have P4O10, we have 6 PCl5, I have 4 PCl3 and 6 PCl3, so I have 10 PCl3, and then I also have 5O2. And my change in enthalpy at this point will be 1,741.7 plus 505.2. So we're up to 2,246.9 kilojoules. Okay, final equation. It gives me Cl3PO. It's in the correct spot. It's a product in the original. It's a product in the data. However, I need 10 of them. The data only gives me 1. So I need to multiply this by 10. So that means I need to add 10 PCl3, 5O2, because it was half, so it's going to be 5, and 10 Cl3PO as a gas. And my change is going to be negative still, because I did not flip it, and it's going to have to be multiplied by 10. So 285.7 times 10 is an easy 2,857 kilojoules. And it is negative. This was our last step, so hopefully everything cancels that we don't need. On both sides, I have 10 PCl3s. I have 5O2s. And if I combine, I am at P4O10 as a solid. I am at 6 PCl5 as a gas. And that makes 10 Cl3PO as a gas. Does that match our original balanced equation? Yes. That means we flipped everything right and we multiplied everything right. It is safe to make the assumption that all that data will cancel out at the end. In fact, it definitely should. That's why they're giving it to you. It's your job to list it all out because you need to figure out if I need to flip it, so flip my sign, or if I need to multiply it or divide it in some way to give me the right amount. So in this case, our change in enthalpy, which is what it was looking for, is this last part here, the 2,246.9 plus a negative 2,857. So that's going to give me a negative 610.1 kilojoules as my final answer. So it will be exothermic, and we will have a release of 610.1 kilojoules.